So we're going to keep going with samples, surveys, and how to ask questions. We talked about some cool stuff today, as in like statistics done really, really, really wrong, and it made for some great stories.
Better than the
Well, the target one was an example of statistics done right that made a spectacularly awesome story. So it's not quite as good as that one. No, that Target story is like the best story, isn't it? Where Target knew she was pregnant before her dad. That's pretty amazing. Of course, you don't tell your parents anything when you're teenagers, right? So maybe Target could know before your parents. All right. So when you are going to use samples to deduce stuff about populations, you have to make sure that your sample is representative of the entire population. As in, I shouldn't just ask college students their opinion about the presidential election because they're not the only group that's voting. Does that idea make sense? Okay. So if you're going to try to use a sample to generalize about the entire population, your sample should be something called a simple random sample. And there are lots of different methods to ensure that this happens, and we're going to talk about different sampling plans that give you a random sample. So that plan is called your probability sampling plan. It's one in which everybody in the population has some specified probability to be selected for the sample. So let's talk about a few of those. The simplest thing, so to produce the most basic simple random sample, the first thing you need is you need a list of all the units or things in the population. So if my population was this class, I would need a list of all your names, and then I would randomly pick out like 10 of you, for example. If my population was UAF, I'd need a random list of all students at UAF, and I'd pick a random sample from that list. And then another thing you can also have is a list of random numbers. And there are, like, I think your textbook has random number lists in the back of it. And you can also find random number lists like online, or computers can generate them. It'll just take the numbers 0 through 9 and like randomly give you one of them. And you can look at them in like 2-digit blocks or 3-digit blocks or 4-digit blocks to get like numbers bigger than 0 through 9. And this most basic method we're going to talk about is sometimes called the lottery method, because how you pick numbers works a bit like how the lottery does. So everybody in the population is numbered, and then a source of random numbers is used to select the sample. So we're going to do that for this next example. So a lottery game is played by choosing 6 whole numbers between 1 and 49, and the grand prize is won if all 6 numbers chosen match the winning number drawn. And so we can think of choosing the winning numbers as the same thing as choosing a simple random sample of 6 numbers. And because your numbers are between 1 and 49, we're going to assign them IDs from 0, 1, meaning the number 1, to 49. And at least for this game, we're going to pretend that you can have the same number appear more than once. So guessing 1, 1, 1, 1, 1, 1 is okay, as in that can be your 6-digit number, your 6 numbers. So we're going to use a table of random digits, in this case, to pick 6 numbers. So your book probably has something like this in the back of it, just a list of the numbers 0 through 9 in a completely random order.
It's supposed to say 2-digit numbers.
It's supposed to say 2-digit numbers, yep. So, and these are, but it gives the list in chunks of 5 so you can easily separate them. So what we're going to do to get our 6 2-digit numbers is we're going to look at these 2 by 2, and we're going to keep the number that we see if it's between 01 and 49. So like our first number is 76. Is that between 01 and 49? No, so don't keep it. The next number is 42. Is that between 0 and 49?
Yes.
Yeah, so keep that one. So 42. The next 2 numbers would make 96. Toss it, right? The next 2 make 97. Toss it, don't use it. The next 2 make 30. The next 2 make 23, so keep it. The next 2 make 39. Can you keep 51? Oh, I was so close. Next we'll have 26. Can we keep 94? No, but how about 43? And then is that 6 numbers?
Yeah.
Okay, so that's one way you could use a random number list to make a list of 6 numbers. When I took basic statistics, like, oh my God, a long time ago, it's like 12 years ago, we were asked in our class to do a coin flip, like flip a coin 20 times, and I was like, this is a waste of my time, this is so boring. So I just made something up. But one of my classmates was really clever, and instead of making something up, he went to the random number list in the back of his textbook, and he said, okay, my coin is a head if my number is odd. My coin's a tail if my number is even. And he used the random number list to make a list of heads and tails that was actually much more random than the one you make yourself. Humans are bad randomizers, and it actually is possible to use statistics to sort of detect when somebody's made up a heads tails list versus actually found a heads tails list. And the reason is that we don't think streaks are very likely when they actually are kind of likely. Like getting heads is not all that unlikely in a list of 10 heads and tails things. So his way of doing that heads tails thing was a much more clever way to not do the work, but probably also trick the professor into thinking they had actually done the work. So
I wonder whether was that more or less time consuming than flipping a corner.
I think definitely less. Oh gosh, yeah. Flip, wait, flip, wait. Yeah, it was definitely faster. Okay. So radio station has a contest each day of the week in which the DJ selects one birthday at random, month, day, and not year, and announces it on the air. And the first person with that birthday who calls the station wins the prize. A new birthday is selected for each of the 7 days, and the station doesn't mind if the same birthday is selected more than once over the course of the contest. So what is the list of units for which a selection will be made? So if we're going to, how many days are there in a year? Except for that once every 4th year when there's... So we don't want to leave those poor people out, right? So let's say up to 366, because we'll include the poor leap year babies. And then we have to start with 001. Does that make sense?
Because there can't be 0 days.
Yeah, there's the first day, there's no 0th day. Like the first day is January 1st. Second day is January 2nd. And then, you just count from there. Does that make sense? Okay. So if the station did not have access to appropriate software, how could they randomly select a birthday each day? So, like, if they don't have, like, a computer to generate it for them, they could...
Throw a bunch of numbers in a hat and pull one out.
Yeah, they could throw numbers in a hat. Now, one thing I'd be careful about, they probably would have to throw these numbers in a hat. So that's the basic idea. Throw numbers in hat and draw. It probably would be also wise when you throw numbers in the hat to mix them so that the way that you cut them didn't affect who's on top, right? Or you could have used the random number table like we had and look for groups of 3 that fell between this. Yeah?
And then is it important to put it back?
Yes. In this case, put it back. If you do the whole...
That's how they would be able to draw.
That's how they could draw the same day. Yep. So if they wanted to not draw the same day, they would have to either keep it out if it was the hat thing, or keep track of what they picked if they were looking at like a list of random numbers, so they didn't pick it again. And that sort of idea of, if you can pick something again, that's called with replacement, because you take something, you pick it, and then you replace it. When you can't pick the same thing, it's called without replacement. We'll talk more about that in like a later chapter on probability. That comes up with stuff like card drawing and stuff, like if you're getting, what's probably you're gonna get a hand of cards, stuff like that.
So we're gonna learn card counting?
Well, we'll learn some stuff. I've got some pretty cool stories about how people cheated lottery systems and made money off of the state lottery system. So I've got some good stories about this. We will talk about it. Okay, so there are different ways to sample, and I'm going to talk about a few of those. So divide the population units into something called strata, which is subgroups, and take a simple random sample from each one. So this is called stratified random sampling. Stratified random sampling. So the idea is divide into groups, randomly choose from each group. So for example, there are about 60 of you in here, right? I could divide you into 6 groups of 10 and then randomly choose 3 people from each group of 10. Maybe I'll divide you into groups based on like your alphabetical order of your name or something like that. Okay, but randomly you make them into groups and then you pick from each group some kind of random number of people. In this next one, you divide the population into something called clusters, which is also still subgroups, but instead of sampling in each cluster, you just pick one of the clusters, or 2 of them. That is called cluster sampling. So for here, let's say 10 groups of 6. Choose 2 from each group. That would be an example of stratified. Cluster sampling is we gotta make like 10 groups of 6. And then I pick 2 of those groups. Does that idea make sense?
If you clustered them randomly, would they still have like the same
Yeah.
variation?
If you cluster them randomly, then they still have equal probability of being chosen. Yes, definitely. It's just that cluster sampling is actually a little bit easier in lots of contexts, so we'll talk about why that is in just a sec.
So you're about to give examples of these?
Yeah, we'll definitely have examples of these, and like, so what the kind of stuff you'll have to do on homework and tests is like, here is how somebody picked a sample. Which of these kinds was it?
I was about to ask, like, when would you use this?
We got some. Definitely got some. Okay, this next thing is done by dividing the population list into as many consecutive segments as you need, so equal to your desired sample size. Picking a random starting point in the first segment and then sampling at that same point within each segment. This is called systematic sampling. And the definition makes it sound more confusing than it is. A good example for this one is assembly lines. So they like check every 100th, we'll say, light bulb. For defects. Does that idea make sense? They divide up into groups of 100 light bulbs and they check every 100th one. And they maybe don't begin on light bulb 1, they begin on like light bulb 17. And they check 17, light bulb 117, and they do it in a systematic manner, always checking after a certain number has gone by. Maybe 100, maybe 1,000, maybe 10, it just depends. Okay, this next one is carried out by having a computer randomly construct and dial telephone numbers, including both landlines and cell phones. Ha ha ha. That's called random digit dialing. Look at somebody random digit dialed you. That's right on cue. Just kidding. And the final thing combines the sampling methods or repeats the same method to successively sample smaller proportions of the population to reach an individual person. That is called multi-stage sampling. Okay. So suppose you've got a class of 200 students, oh my gosh, 60 is already too many, and they're numbered from 1 to 200, and a table of random digits is used to choose 60 students from the class. Is the group of students selected a simple random sample, a stratified random sample, a cluster sample, or a systematic sample? So which one do you think it is? And then we'll eliminate all the rest for sure. Simple random sample, yep. And let's talk about why not all the others. So why not stratified? Were they divided into groups first? No, that's the reason why not stratified. Cluster, were they divided into clusters and then one cluster was chosen? No, right? Did they pick every 7th student? No, so that's why it's just a simple random sample. Okay, so let's take a situation and let's talk about what the samples would look like if you sampled from the situation in different ways. So suppose you have a state that's bigger than Alaska, and this state has 10 universities, 25 four-year colleges, and 50 community colleges. This is not unreasonable for most of their states in the Union. It's just Alaska and Hawaii are special. So in each of which offers multiple sections of an introductory statistics course. Researchers want to collect a survey of students taking introductory statistics in the state. Explain a method for collecting each of the following types of samples. So a stratified random sample. So in a stratified random sample, you divide the population into subgroups that make sense. And so in this particular example, we have 3 different kinds of post-secondary education. Does that idea make sense? So what we're going to use as our strata, we're going to use the schools. So use the type of school as strata. And specifically, that is university, which usually means that includes some kind of like graduate studies, like a master's degree or PhD program. 4-year colleges, that's only undergraduate. And community colleges. So use your types of schools as strata. Once you have your strata, you need lists for each strata. So second step is to create a list of students for each strata. I hate it when this happens to me. Sometimes I have to use whiteout. Okay, now once you have your groups, what do you do with those groups? Randomly sample from each of the groups. So randomly sample. And the kind,
Just sample the same amount from each group?
not necessarily, and in many instances it might be wise not to. If there are a lot more people at a certain kind of school, you might want to sample a disproportionate number of people from that school to get equal proportions to what the actual proportions are. Does that make sense? Yeah. And the hard thing about this way is that you are going to be asking people at possibly every single different school a question. Does that make sense why that's kind of challenging? Because it's possible that you could get students at every single place, right? Because once you divide them into strata, they're still mixed up, right? But what this does ensure is that you get students at every kind of school. That's one benefit to this. So benefit, you get people at every kind of school. Disadvantages, you could still have to ask a lot of different places. That's a problem. Okay, a cluster sample, what you could do with this is you could use individual, either schools or classes as clusters. I mean, it's probably reasonable to say that among these schools there are a couple hundred statistics classes, right? And then you could randomly choose a few schools or classes. And then you would survey that whole class or that whole school, stuff like that. Does it make sense that that would be a lot easier? It'd be easier to ask just one, like one class at 5 different schools. And you could also kind of combine this with the previous one. You could say, okay, well, I have these different kinds of institutions, and I want to make sure I ask 2 universities, 4 four-year colleges, and I want 8 community college classes. Like, you could kind of also combine those methods a bit. But the basic idea with cluster sampling is that you divide them into groups and you pick a whole group. And that might not be as good because if you ask the people all at the same school some question, they might have similar opinions as opposed to at different schools, opinions might be very different. So there are disadvantages.
So it doesn't have to be just one cluster?
No, you could pick like 10 different clusters.
Okay,
But the point is you pick them in groups as opposed to randomly everywhere.
sure.
Yep. Okay, then a simple random sample.
Get a list of all students' names from all schools.
Uh-huh, get a list of names, yep. Get a list of names of all students at all schools.
That would be fairly hard.
And randomly sample from this. Yeah, I think
Because there's laws against, that sort of information being shared.
it depends, I think. But the point, yeah, so there would be permissions that would be needed for all sorts of stuff. But the point is that even if collecting this list wasn't hard, disseminating the survey and making sure that it was filled out probably would be. So ignoring the whole, like, can I actually ask students questions in the first place question, even just the question of what do I do once I pick my people is a lot harder. That's kind of the idea. So those are different types of samples, and what you'll have to do in your test probably is just classify, like, what kind of sample was this thing that I chose. Does that idea make sense? Okay. All right, so now we get to talk about difficulties and disasters in sampling. This is super fun because all sorts of stuff went wrong. So thing number 1 that can go wrong, you can use something called the wrong sampling frame. So the sampling frame is the list of units from which the sample is selected. Using the wrong sampling frame might include, I said this just a little bit ago, asking college students who they will vote for. I don't know why I wrote for with an E, it just happened. And trying to predict the election.
That's a small number.
Well, a small number isn't always the problem, because I could ask 500 college students. That's a reasonably big number, and that's not a great margin of error. But the problem isn't the number. The problem is that the students are not a random sample of the electorate, and so you have to sample. I mean, even the fact that they're all the same age is one thing, not to mention that they all live in the same state, which all live in the same town, and people tend to have different opinions when they live near each other. It happens a lot, and so that's a lot. There are lots of reasons why this is bad. So this doesn't get everybody. Not reaching the individuals selected. So, for example, if you use landlines to conduct a survey. So even assuming everybody wants to answer your questions, okay? So pretend like you do a survey and you call somebody and you don't interrupt them at dinner and they do have time to talk to you for however much time you need. Even if all those things work right, why are landlines a problem?
Nobody has a home phone.
And if somebody does, what's their average age probably? Old. Yeah, right, old. I think I'm probably the one person under the age of 40 who doesn't have a cell phone.
Your
So,
landline probably came packaged with like a TV internet deal though.
and the cell phones don't work at my house because I'm in a weird fold in the topography, so it's just, yeah, but, and my sisters, they have to work harder to call me. So, that's one problem with landlines. You might get a disproportionate amount of older people if you do that kind of sample. Non-response, volunteer response, and non-participation. So this is stuff like people don't tend to participate in mail and call-in surveys. There's notorious non-response there. So people don't participate in mail-in surveys, stuff like that. So even though you pick a good sample and you mail out your surveys, it doesn't matter if half of them don't respond, because that in and of itself could introduce some biases. They could have something in common that you don't, people that don't participate could have something in common that you can't sort of forecast. So when people do surveys, they go through a lot of effort to make sure that you answer. I got somebody in my college graduate survey where they sent me money and repeatedly bothered me to get me to do their survey. But that was not what I meant. Okay, next slide. A blank sample consists of individuals who pick themselves to volunteer or participate. So that is called a self-selected sample. People select themselves. Ooh, do you know there's a good example with reference to college that is a good example of a self-selected sample. You use it to rate your professors. Right? This website, ratemyprofessor.com, is an example of a self-selected sample, right? As in, people decide to go there and talk about somebody. They decide if you get a pepper or not, stuff like that. So, and this is a problem.
That website is getting really messed up.
Yeah, and that website has problems for reasons of which could include people can create multiple accounts and survey you more than once, and they could either be, and usually that's in an effort to be nasty. But, so why is this a problem?
Because people with a specific bias.
Yeah, a bias that's been observed is that people who have strong opinions, and often negative ones, tend to respond more. So, that's definitely been observed. Okay, a blank sample is constructed using the most convenient group available to decide on this, and they decide on the spot who to sample. That's called a convenience sample. I mean, for example, I could use you guys as a convenience sample. It's super easy for me to just ask you guys about opinions about people at UAF, and that is sometimes reasonable, because you are hopefully a representative-ish sample of UAF, probably.
Considering we're in this class.
Yeah. Okay. So a local government wants to figure out if taxpayers support increasing local taxes to provide more public funding to schools. We've already talked about this one a little bit, haven't we? Yeah, they randomly select 500 school children from a list of all children enrolled in the schools, and they survey the parents of these children. I went kind of Frenchy there. What is the population of intereste? Interest, obviously, is typo for the local government. So who do they care about? Just parents or all taxpayers? All taxpayers. You could also maybe say all adults, because or you could say eligible voters. You should probably make it clear that they don't care about the opinions of children. Does that make sense? Okay. What sampling frame? So what this means is, what population did they draw from? Yeah, parents of school children. Okay, I mean, that doesn't include parents of children whose kids are not yet in school or have already been through school, right? They wouldn't be included. That depends, because I worked in the school district, so I know this. Homeschooled kids tend to have to be kind of registered with the school district, so they probably could still find them that way. Yeah, there's a program. Yeah, yeah. So there's a system that probably keeps track of those people. But you're right, it's possible that, depending on their way of sampling, they may have not gotten those people. It's definitely possible. So explain why the problem called using the wrong sampling frame might lead to a biased estimate of taxpayer support. So do you think, if they do this, do you think they're probably going to see more support than there actually is in this group or less? More. Yeah, they're probably going to observe more support in this group. So more support in their sample compared to the general population or electorate, compared to the general. As only parents were chosen. So that's the problem with using the wrong sampling frame. So you have to ask yourself when you design these sort of studies and stuff, does my sample encompass the population that I care about, or did I pick it from a different subpopulation that might have some opinion in common? Okay. In each part, tell me whether the sample should be called a self-selected sample or a convenience sample. So to assess passenger satisfaction, an airline distributes questionnaires to 100 passengers in the airline's frequent flyer lounge. And all the 100 individuals responded, and 95 said that they had a high degree of satisfaction. That is definitely a convenience sample. And call me crazy, but that is the wrong group of people to ask about satisfaction with an airline, right? They're probably the ones sitting in first class. If they're in that fancy little like lounge in Seattle, because they're running the fancy little boardroom lounge, it is super nice. Of course you're happy. They're giving you like free food, free wine. You're fine. If you're out.
Free.
Yeah, I mean, like you pay for it, and then it's sort of free if you go above a certain threshold, right? Yeah, it's not actually free. It's free-ish. Anyway.
Economics, there's no such thing as free lunch.
No, there is not. Okay, a magazine contains a survey about exercise habits. Readers are asked to mail in their answers, and 2,000 people do so. What's that called? Self-selected. And one problem that might occur there is maybe only people who are very happy with their exercise habits mail in, right? People who are depressed and are like, didn't exercise, are like, I don't want to admit that I was bad and didn't exercise.
Would that change to a convenience sample if the magazine somehow knew X amount of people exercise on a regular basis? Like if they only sent it to people who they know work out 5 times a week, would that then be a convenience sample?
No, a convenience sample is really just that you have this group of people in front of you and you survey them. So, I mean, it could also, another example of convenience sampling is something like, sometimes in malls they have little like kiosks out where they then just ask you to come up, that kind of thing can also be sort of convenience and self-select at the same time. If you're at the mall, they ask you to do it, so you're convenient, but you also self-select to actually do it. So you definitely could be both. You're not necessarily one or the other, but these really are one or the other. Okay, so here's the infamous Literary Digest poll of 1936. This is a great story. This wasn't the only time this happened. So, election year 36, Franklin Delano Roosevelt versus some guy named Alf Landon, who won. If you know any history, it was obviously this guy, right? Because he was president during World War II, yes? Yeah, okay. He's the only president who has done more than 2 terms, yes? I think, not a history buff, but I'm pretty sure that's correct.
Yeah.
Okay, so before, Literary Digest had correctly predicted many presidential elections. They surveyed 10 million people and 2.3 million responded, okay?
Wow.
That's a lot, right? Okay, so so find the margin of error. So remember that the formula that we have for that is 1 over root n. And do we use the 10 million or do we use the 2.3 million? 2.3, because they actually responded. So 1 over 2, 3, 1, 2, I think that's 5 zeros, right? So that's approximately 0.00066, or as a percent, 0.066%. Do you guys agree with that? That's a pretty bitty margin of error, right? So they're like really confident, like, oh my gosh, this Alf Landon guy, he's gonna win. He's our next president.
Still, that's a small number compared to 10 million.
Sure, but it's a really small margin of error. Usually if you have a good sample, that many people is gonna give you like a lot of accuracy. But little George Gallup, you guys seen this name before?
No.
If you follow any presidential polls, there's an organization named after this guy. There's lots of Gallup polls. If you look up like Google presidential election standings, blah, you'll get things that say Gallup on them. Okay, it exists. He surveyed just 50,000 people, and let's find his margin of error. 1 over root 50,000. It's also pretty small. It's about 0.0045. What's that as a percent? Which is also a pretty small margin of error, right? Okay. So who won? FDR. And the big sample did not guarantee, actually, that sample is what, like almost 5 times larger, right? Okay. And so the question is, what happened? So what went wrong? Okay, so without me telling you more, there is one definite sample with one problem with the Literary Digest sample. What's one obvious issue? They surveyed 10 million people and got 2.3 million responses.
Literary Digest, that means it's even A for one group of people who get the.
That's kind of the idea. So non-response is one potential problem, but that wasn't the really big problem. The really big problem is that, yep, so Literary Digest used the following things to get their names. They used magazine subscriptions.
People with money.
Yep. They used car owners,
People with money.
people with money, and they used telephone directories. And that isn't obviously people with money until you remember that it was 1936, and a telephone was a big deal. I don't know what year the there was an act that brought telephones to rural places, right? And I don't know what year that happened, but I suspect it was post 36, right?
But still, 2
Also,
out of
that
3.
sample's almost 50 times the size, not 5.
Oh, 50 times. Okay, sorry, I can't multiply. I don't multiply well. But it's a lot bigger, but not more accurate. And the real problem is that this sample was non-representative, and there were a disproportionate amount of wealthy people. And you guys know 36, that is the Great Depression, right? People who were poor probably cared a lot about what the president was going to do for them, and one of FDR's big things was the New Deal, yes, which put people to work, and then there was World War II that put people to work too. So, but the point is that super non-representative sampling. There's another example, was in a different presidential election where they even printed the paper saying that a certain person was going to win. I think that was Truman, yeah, right? Truman and Truman won and Dewey lost, right? Yeah, and some state, maybe Chicago, had printed papers saying that Dewey had won, and it was the same kind of problem. They didn't learn their lesson. So, here you go. Okay, other problems that can happen when you ask survey questions. So sometimes people can put in some kind of deliberate bias. So a good example is questions that begin with something like, do you agree that? And I think that certain parts of divisions of psychology have looked into like the way that you word questions and how does this influence how you respond to things. Influence what your responses that you get. You can ask people questions that effectively are the same thing, but you get different responses based on how they're worded. Unintentional bias. So, for example, if you ask about drug use, you need to specify if you mean legal or non.
And there's a lot of drugs out there, even in the legal or not.
Yeah, but I mean, even like that aside, do you use drugs? Well, yes, I use ibuprofen. That's technically a drug, but what are you asking me? Like, does that make sense? You need to be very specific in how you ask your questions. Another example, I just kind of blanked for a moment. Let me just think. Ask about being fired versus laid off. Does that make sense? That if you word the question with fired, people might say, oh, I wasn't fired, I was laid off. Or the company downsized. You need to make sure you... Does that make sense? That could also influence the results you get? And most of those are unintentional. So 94, the current population survey, CPS, which is used to determine government and unemployment figures, people were answering that they were laid off as a euphemism for being fired. So if the sheet didn't ask for laid off, it asked for fired. So is this deliberate or unintentional bias? Probably unintentional. Another thing that can go wrong is, especially if you ask people questions that deal with behaviors that are socially unacceptable, you can get people that sort of lie or misrepresent how much they do. So a good example is voting. So if you ask people whether or not they voted in the last election, like you ask them to their face, not just like through a computer where you can't see who they are, why might they say that they had even though they had not?
Guilty?
Yeah, they feel guilty, so maybe they don't want to admit. Oh, the guilt. And this is an example of the desire of respondents to please the interviewer, that they don't want to say something that makes them look bad. So I guess they could even phrase it as not so much please the interviewer as not look like a fool or something. Now, additional problems can occur when you do a couple different things. You ask the uninformed, you ask questions that are unnecessarily complex, or even putting questions in a particular order can be a problem. So lots of late night TV shows do goofy stuff like this. Like they'll go ask people, oh, what is gluten? And then they give all sorts of wacky answers because people have no clue. Of course, like the TV show picks like the most crazy, awful, offbeat ones to show you. But somebody did this study, and they asked people about a group called the Wizzens. They're like, oh, do you know this group, the Wizzens? They're terrible for America, blah, blah, blah. Went off. And they were fictional, okay? The Wizzens were fictional. I think I spelled that wrong. Y-Z, like that maybe. And this was a fictional group. And 30%, that's a pretty big number, of people had an opinion. So the moral of that story is that when you don't know, just say that you don't know. Don't pretend that you do. So, what do you think about these Wizzens people? They're terrible for America. They're fictional. Okay, so we should read about that. Probably is pretty funny. They should have filmed that. Would have been awesome. Okay, so in a survey, people were asked the following two questions. How happy are you with life in general? And then how often do you normally go out on a date? Which order would you expect to produce answers that were pretty related? This order or the opposite? The opposite, yeah. So first we're going to ask you about your dating habits and prime you to either feel happy or depressed. And then we'll ask about how happy you are with your life, right? You might be reminded that, oh, I haven't had a date in ages. Aww. Whereas before before you'd seen that question, your answer might have been different. I should have done this on you guys to see if it actually had an impact.
Oh, darn.
Oh, darn. Okay. So explain which of the three methods, a door-to-door interview, a telephone interview, or mail survey, would be most likely to suffer from each of the following problems. So in which one would bias due to desire to please the interviewer be the biggest issue?
Door-to-door.
Door-to-door. Volunteer response is another way of saying non-response. Yeah, I think it would be worse with the mail survey. Do you agree that volunteer response would probably still be a problem in door-to-door, but less of a problem?
Yeah.
You can probably get something out of somebody if you get them like right in front of you, right?
Not everyone's gonna slam the door.
Not everyone's going to slam the door on your face because they're less likely to be rude to your face, but not mailing back a mail-in survey is easy to do even if you intend to do so.
Sorry.
That's okay. Were you stretching?
Stretching.
Okay, great. And then bias due to perceived lack of confidentiality.
Telephone
Telephone could be a problem,
and/or
and door-to-door.
Well, and mail-in survey, because you don't know who can see it once.
Yeah, I mean, really, I guess all of them, but in some ways I think door-to-door might be the worst, right? Somebody now knows where you live and knows your face. Versus telephone and mail-in, I mean, they kind of know where you live on a different, like, abstract level, right? But, and also, even with mail-in surveys, they wouldn't necessarily have to know your physical address. Some of us have P.O. boxes.
or like they just send a bunch of stuff out that says current resident at, and then your address. below.
Exactly. So, probably door-to-door is the worst. Okay. And the last thing we're going to do today is we're just going to go back and look at these confidence intervals again. And this one, we're actually going to find two of those confidence intervals and talk about how having two of them allows us to look at the differences within two different groups. So there was a survey done on faculty at the University of California, and one of the questions asked was, do you favor using race, religion, sex, color, ethnicity, or national origin as a criterion for admission to the University of California? So some schools do this, and I think the Supreme Court just ruled that it was legal, actually, that they could use your race to, like, say, up your chances of getting in. So if you're a minority, they give you a bit of a boost because...
They had to do it to favor school diversity.
So yeah, there's lots of reasons for and against it, but the point is that sometimes this happens. And we have the opinions of different faculty members. So of the 166 arts and humanities faculty, 66% favored the policy. And in the engineering and mathematical and physical sciences faculty, only 38% favored it. And do you agree that those numbers seem to kind of make sense based on personalities of people in those departments? Yeah, probably. Okay. So find the conservative margin of error for the arts and humanities faculty and use it to find this approximate 95% confidence interval for the percent of people in population who favored this policy. So for the arts and humanities people, we'll use this 1 over root n formula. What is the n for them? Exactly. And that's about 0.078. So here I want you to always use at least 3 digits because I would like your percent to have 1 decimal past the percent point. Does that make sense? So that's what percent?
7 point.
So that's your margin of error. And your confidence interval, which I'm going to call your CI, is found by taking the proportion of those faculty members who favored the policy, which was 66, and plus or minusing 7.8%. And usually you give the lowest number first. So you do 66 minus 7.8, and I got 58.2%. Does that seem reasonable? And then 66 plus 7.8 is
73.8.
How about the other people, the engineering and sciences people? What do we use to find our margin of error? 1 over n will be 1 over root 229, which in this case I got was 0.066, which is what percent? Okay, great. And what is the proportion I use for the confidence interval this time? 30. So that gives us 31.4% to 44.6%. Okay, so we have, I'm just going to draw a little visual here. So for the 10, 20, 30, 40, 50, 60. Okay, so for part A, our interval was 58.2 to 73.8. So 58 to 73. And this was for the arts and humanities. The other group was 31 to 44.
Could you lift it up a little?
Definitely. Is that good? So that's sort of visual of what those two intervals are. Does that make sense? Okay. Part C asks, do you think these numbers are actually different? Like without having to do a chi-square analysis, do you think the proportion of math faculty versus arts and humanities faculty who support this policy actually is different? And what do these two intervals suggest? Yeah, they are. And the reason that you can say is, well, these two intervals don't overlap at all. Like they have nothing in common. So yeah, it's probably very likely that these things are different. And you don't even do a hypothesis test for that. You can just pretty much say from those intervals not overlapping that yes, they're different. So since these intervals don't overlap, we conclude that the proportion of faculty who favor this policy is different between these departments.